Great, the Wi-Fi module works, so let's go ahead and do something useful with it. Automation and remote control fits well in that category. You may remember back in lecture 38 that you learned how to control an LED by setting up a simple web server on the Arduino. You used your web browser to access this web server and click on buttons to turn the LED on and off. We will adapt that sketch to use the Wi-Fi module instead of the Ethernet shield in Demo 3, but in this demo we'll try something different: polling-based control. In summary, we will use instructions contained in a text file hosted by a web server somewhere on the internet. The Arduino will use the Wi-Fi module to get this file, read its contents, and turn an LED on and off accordingly. This schematic shows what is going to happen. In this second demo, what I'll show you is a way to control this LED, which is, by the way, connected to digital pin 8 via a 1 kilo ohm resistor to the Arduino using what's called a polling method. So with the polling method, what the Arduino is going to do is try to access a file or a web resource somewhere on the web which contains instructions telling the Arduino what to do. In this case, to turn this LED on or off. Now, the instruction that the Arduino is going to be looking at is written in a simple text file. So you may remember from the lecture on the Ethernet shield, where we were able to use a GET request on a web server running on the Arduino, and that GET request contained the LED instruction. In this case was the word LED followed by a number that represents the digital pin to which the LED is connected, and then the 1 or the 0 would tell whether the LED should be turned on or off. So this text file represents this web resource that the Arduino is going to look up every few seconds or minutes in order to get instructions telling it what to do. For this demo, I have uploaded this file cc3000.txt onto my Amazon S3 account. So it is this file here. I'm using this tool to make it easy for me to upload and edit these files on Amazon S3. You don't have to use this kind of setup. If you have access to any web server that is accessible from web clients or web browsers, then you can just drag and drop any text file to your web server, and this example will work just the same. Demonstrate further, I use my web browser, and this is the URL that this file listens to. So if I specify this URL in my browser and refresh the page, you'll see that what comes back is just the text content of this file. I'll make a little change. So I'm going to change this one into a 0. Whoops. A 0. And save it. Then upload the new version of the file onto Amazon. Replace the old version. Then refresh this page, and you'll see that the new instruction wants the LED to be turned off. So the Arduino via the Wi-Fi module will be doing this reload of this resource every about 10 seconds, and that will have the effect of turning the LED on or off. So before I show you how the sketch works, let's upload the sketch to the Arduino and make sure that it does work. So uploading. All right, have a look at the output. Connecting to my Wi-Fi network. All right, connected. So it made a request to the URL, I grabbed the instructions from this file, parsed the instructions, and then executed the instructions. Done. A few seconds later, it's going to do that again. So how about now we try to turn the LED on by changing the 0 into a 1, saving the file, and then uploading it again to my Amazon bucket so that it replaces the original file. Alright, done. Let's have a look. Next time this loads, it should turn the LED on. Okay, and it did. The LED was turned on. So polling is really good if you want to control something that doesn't have to be controlled in real time. So a few seconds in between updates is enough, especially when you have issues with getting through proxy servers and firewalls. It's because the device itself is going to look up an external resource that usually is allowed by proxy servers. So that's a pretty good method to do things like home automation. Maybe not so good for robots and things that require faster updates. So since this now works, let's have a look at the sketch and see how it does it. So the first few parts of the sketch are similar to those from demo 1. There's nothing new here. The settings for the Wi-Fi module are the same. I'm creating the CC3000 object just like we did earlier. Then I've got these two Boolean and string variables, reading and get request, which are going to help me do the parsing of the instruction from the text file. At this point, you might want to go back to the Ethernet Shield lecture and have a look at that lecture, because those two variables were introduced back then. So if you are having issues of understanding how what these two variables do, then go back and have a look at that lecture. There's nothing new here. We saw that in demo 1. Now here's a new definition of a constant. What I'm saying here is that I'm defining 3000 milliseconds, or about 3 seconds, as the maximum time that I expect that a web server will take to send a response back to me. So that means that I'm going to be using this number later on to only wait for up to 3 seconds for a web server to respond to a GET request. Come back to this in a minute. This is where I define the location of the resource. So this is the URL of the web server and the resource that I want to get, the text file. Okay, these are the same as before. In this declaration, I'm creating a web client. Right, I'm calling it www and of kind of class Adafruit CC3000 client. Not much happening in the in the setup function. I'm just checking out to see how much free memory I have. Then everything is happening inside the loop function. So I start with increasing an integer counter by 1. I just use this counter to see how many times my Arduino has requested for this page over a period of time. So you can see here, just stop that, that up to this point, the Arduino has made in total 10 requests for this text file. So that number 10 is kept tracked by using the repeat counter integer variable. Initialize Wi-Fi. So I've created a few functions in order to break down all the functionality that in demo number 1 we saw in the setup function. So I want to make things a little bit simpler. So for example, I've broken down the, I'll go a bit further down. Okay, I've broken down the way by which a host name is being resolved by DNS into its own little function here. So I'm just going to call that by name. Same thing here. In order to initialize Wi-Fi and connect to it, I've just broken down these lines that used to appear in the setup function in demo number 1 and its own small function. It's just easier to handle it like that. Delete all connections, old connections, so the profiles. I've also got DHCP, the call to the DHCP server. Again, same functionality as demo number 1, but now broken down into its own small function, which is easier to handle. Yeah, connect Wi-Fi. And also have connect TCP, which creates a TCP connection to the IP address to which the Amazon web server is listening to. In your case, will be your own web server, and that will be port 80. All right, let's go back up to the loop. So initialize the Wi-Fi module and delete any old connection profiles. I connect to my Wi-Fi network. I get a DHCP server to give me my credentials for the network. Then I look up the IP address for my web server. Now, at that point, I'm going to connect to the remote web server via TCP. And now this part is a little bit tricky. It seems like that the Adafruit library that we're using in this example has a few rough edges, and after a few repetitions, it segments the memory of the Arduino so much that eventually the Arduino stops responding. Essentially, it freezes, just like sometimes a PC freezes and becomes unresponsive. I believe that this is happening because of memory fragmentation. So that means that memory becomes fragmented with empty space allocated all over the place, but each fragment being so small that is unusable. I've got some information and a write-up in more details about this in the notes of this lecture. So please go and have a look at that. It's probably good to understand what fragmentation is, because the Arduino only has a couple of kilobytes of static RAM, and that, without much care, becomes quickly fragmented. Now, this function here is a watchdog timer. That's what WDT stands for, watchdog timer. A watchdog timer looks at situations where the Arduino becomes unresponsive. So, for example, there is no heartbeat, as it's called in it. A heartbeat indicates that the Arduino is running normally. If the watchdog does not detect the heartbeat or any functionality, then it would reset it. So it would reset the Arduino would go back into loading the sketch from its flash memory and start executing it as if you had just uploaded it or hit the reset button. So that is going to have the effect of memory becoming defragmented and then your program starting to work again. So that's what happens here. After a lot of experimentation, I realized that the problem with causing the fragmentation and the program and the sketch to freeze was isolated in this call, this function call. So I enable the watchdog timer just before I call connect TCP, and then disable it right after I call TCP. Hope this makes sense. Have a look at my notes, and if still it doesn't make sense, please let me know. Send me a message. Once we have connected to the web server, then go ahead and make the GET request. So this is a call to a function that constructs the GET request bit by bit. Let's have a look at it. So here's make GET request. So we go to the web client object. We call its fast print function, and we start with passing the get keyword, so the get verb, this is the URL that we want to connect to, and that we're saying to the server that we'll be using HTTP version 1.1 and sending a carriage return as well. The host, the website, and another carriage return here, and an empty line, and then we'll pretty much finish. And that makes up the GET request. Okay. So hopefully this succeeds, the request is sent, and then we start listening for a response. So we want to keep track of time when the last read was, because we want to make sure that we don't wait for too long. We don't wait forever for a response. Remember, we set a constant idle timeout ms for 3000 milliseconds. So with this expression here, we ensure that we are only going to wait up to that amount of time for a response. And if nothing comes back within that amount of time, then we assume that perhaps the web server is not functioning and we're just going to give up and close the connection at the end of this while loop. Now in here, I'm not going to go through all of this because essentially exactly the same thing happens as what we saw in the Ethernet Shield lecture, where we pass a response to our request. We'll look at the lines. Essentially, we are only interested in this instruction, and we are going to discard everything else. So the only difference between now this sketch and the Ethernet Shield sketch is just this. Because now we are making a GET request, the response that comes back is going to contain the response header, which are things, the first part of the response, which we are not interested so much about. And then there is a blank line, and after the blank line is the instruction that we want to read. So that's when we start reading. And when reading becomes true, then we start collecting character by character the contents of the instruction. Exactly the same thing as what happened back in the Ethernet Shield lecture. Once we finish reading, and we know that we finish reading because we get a carriage return at the end of the instruction. So here, right after the end, there is a carriage return or a new line character. Once we detect that, we know that we have finished reading an instruction, and we're going to go ahead and pass it. We call the pass get request function, and we pass the instruction to it. And here it is. So this function, again, is identical to the one that we saw back in the Ethernet Shield lecture. So please go back and have a quick look at that if you don't remember exactly what is happening here. Once the parsing completes and we know which LED is it that the LED, which pin number is it that the LED is connected to, and whether we want to turn it on or off, then we'll call the execute instruction. This one here. Again, identical to the Ethernet Shield lecture. That's about it. Once this finishes, we close the connection to the web server, we disconnect from the Wi-Fi network, and we wait for 10 seconds before we try again with a new connection and a new GET request.